Hello, this is Robert Guderian, and this week we are looking at data structures. We've actually already seen one of these, potentially two, and this is the way that we're going to hold more than one piece of data in one place at one time. Last week, when we were talking about loops, we also saw lists because they work together so nicely. We kind of moved that up one week. But that was our introduction to a variable that held more than one piece of data. There was a list of data. And lists we can understand quite easily in that we maintain lists in our real lives. We have grocery lists. We have shopping lists. We have to-do lists. We have lists to do many things. So it's a very easy transition to think, okay, well, this is a list that's held in a variable. But that is more than one piece of data. And that is an object. Primitives, and this will pop up next week when we talk about functions, but it's good to start thinking about this now. Primitives are a single piece of data, something that we can encode into 64 bits of data. That is numbers, and in most programming languages, characters too. Unfortunately, Python isn't most programming languages. It's just a string. But so when you're thinking about primitives in Python, it's just numbers, floating point or integers. Well, integers are special, but it'll work. I want to tell you so much about encoding, but I'm going to move on because we're talking about data structures. These are more than one piece of data. These are all objects, every single one of them. And my definition for this course, which is pretty loose, is data and methods to work on that data. And what we'll have is more than one piece of data. And data is actually a plural word. There's two types of data structures, sequences and non-sequences. Today, right now, in this recording, we are talking about sequences. You've already seen one. That is list. It is many things stored in a single variable, and it maintains order. I'll let that set in for a second. It maintains order. This is really important to us. Imagine if your to-do list got randomly swapped around when you added something. That'd be really bad. Imagine you're queuing for your Tim Hortons double-double, and every time somebody gets added, everyone has to randomize. It would be hell on earth. And that's true in programming too. We can't... We need this. The idea of maintaining order is so important to being able to make an algorithm that it's fundamental. So that is what our sequences will do. If we have a list, if we add something to the front, it will add to the front and everything else will shuffle back. If we use .append, it'll append this to the end. And it'll maintain the list, the sequence of pieces of datum in our big string of data. Datum is singular for data. Learning words today. Okay, anyway, it also means that we can access these by index. So that means that strings are actually also sequence data types. It maintains order of all of the letters in your string, and you can access those letters by index. So it is a sequence data type. When I say index, I'm just going to fly over to some code. Oh, that's me. Hi. We can, of course, program in either one of these windows. I'm going to just do this over here. There is a number of ways to make lists, as we've seen, and that is the sequence that we already know. So I'm going to say my list is equal to list function. Now I have an empty list. I can probably see that in my variable explorer. Hey, square brackets, classic. So I can say my list.append one. Can I do more than one thing? I'm playing with code on video. I can't. I didn't think so. Oh, especially with those commas. Yeah, I didn't think so. Gotta try once in a while. Just 2, 3, 4. There we go. I have a list. It has an obvious order that we can see. It doesn't have to be ordered, as in monotonically increasing numbers. But in this case, it is, and that's just for mental state so we can actually understand what's going on. I can say my list at spot 0, and that will give me the first piece of data. Or I like to say 0th piece of data, just to make sure that we actually talk in the same parlance as index at 0. So those are important things. We add data, it'll always maintain our order. It is a sequence of data. It'll maintain. And lists are really good at holding homogeneous data, one type of data. Of course, Python doesn't hold us to that because it's trying to be nice, which is bittersweet. 5. So it'll let us do stupid things like that. Don't. This is not what it's good at. If you're iterating over this data, you're going to make an assumption that it's holding all numbers, and then it's going to parse the word 5 as a number, and it's going to say, no, I can't do that. It's going to throw an exception. So that's bad. Lists are really, really good at storing ordered, homogeneous data. We can also use .len on it. That's important too. It does have a length. We know how many pieces of data are in there. Hey, do you know that it always maintain ordered? But there's another one. So I've been harping on this. This should be homogeneous. Tuples are good for heterogeneous data. And this is really nice if we have a bunch of pieces of data that might not be the same data type, but are all about the same thing. So let's think about a human. A human has many different attributes, and we can start tracking these attributes in code. So over in my code, I can make a tuple. Tuple or tuple, jury's out on that one. I think I switch between them, but I'm not certain. So my tuple, apparently I just said tuple. Oh dear. And they are immutable. That is actually the next bullet point that I just missed. So I have to actually create it with the data I want. So what are some facts about me? Well, I have a student number, 6795723. Wow, I still remember that. I was issued that in 2002. I have a name. My first name is Rob. My last name is Guderian. And I happen to currently be 36 years old. So those are all facts about me. But they're not all numbers. And even my student number, you wouldn't want to treat like a number. It's an identifier. You're not going to say, like, let's add 10 to it and put it through some kind of function to see if it's at right angles with a plane. No, that's not the kind of number it is. It is just a number that represents me. But so does my name. Rob Guderian is my name. And what we'll start seeing is that we'll have multiples. That's where tuple comes from. Multiple. Where, I don't know Heather's student number. I think she's got a lower student number than me. And her name is Heather. Oh, and I do know how to spell that. Oh! Heather Guderian. No. Matheson. Son. I have no idea how old she is. Society tells me I'm not allowed to ask. There you go. So now I have two different tuples, and you'll notice that the order of the indices matches. The first one is going to be always the student ID, and then a first name, and then a last name, and then an age. And the second one is going to be the exact same thing. First, last, age. And there's going to be more. 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 And if I started storing these in a list, I could make a database. And then each one of these turns into a column. Well, that's interesting. So I do have a list in here, and that order may matter. And from my view of my tuple, I don't really know. But here, this order matters too. So I have two dimensions of order. And that's what tuples eventually are very good at. They are lightweight objects. Where we can store a collection of data, but there's no methods to work on it. So that's why it's lightweight. If you had a proper object, I would have a dot birthday or some method, which would increment my age by 1, because that's how birthdays work. I might have a change name function that would have some validation to make sure that the name that I'm providing, that I'm wanting to change my name to, is valid. So I can't make my name be ampersand. That is the worst ampersand I've ever made. Let's try that again. I know how to make them. That's not a valid English name that Stats can, or I guess whatever department of Canada, they won't accept that as a name. So change name would validate to make sure that I can be registered under that name. So that's the difference between an object and a tuple. But the tuple is still important and still very useful. And we're going to use them for a few clever things. One interesting thing is that they're immutable, like strings. This has some very good purposes for next week, which is when we're passing data as reference. Spoilers, it's cool, but we're not going to get into it. We can still fetch these by index. So if I jumped over to my code, if I wanted to say my tuple, can I tab complete that? Yay, I can. Sub 0, guess what? It's my student number. Shouldn't be a surprise. There's quite a number of ways to make these. Python is a little too friendly in this regards, where, again, know how to write one of these, know how to read all of these. It's magical. It does interpret the parentheses, braces, as a tuple if there's a comma. The last one is kind of wild. Because if you have a trailing comma, then it'll know that it's a tuple. If you don't have this trailing comma, it's going to think it's math parentheses and then do order of operations. And it'll say, I'm going to do the braces first. There's no operations here. Let's evaluate this. Thanks, Python? I'm not sure. There's also something called unboxing. This is exactly what we have here. This is it boxing a bunch of pieces of data into a tuple, because I'm asking it to store 3 pieces of data into one tuple or one variable. And it's like, I can put this into a tuple. Yay, send it. Yeah, it's pretty cool, actually. I like it. But you can also call a function that returns an array, and we've seen split, and it'll store it into a tuple for us. So if I had 2 strings, I'm going to use my name, Robert Guderian. I'm actually going to do this in the code over there, so you can run it later. Good. So now I'm going to say first last is equal to myster dot split. Okay, then I'll just say, do some print stuff. Yeah, always feels good. Hi, comma. Oh, I know the syntax for this. I'm going to give myself a moniker. I'm going to use single quotes so I can give myself a nice moniker. Moniker. My moniker is moniker because I'm so meta. Exactly 2 people in this class think that's funny. Dot first format first last for you 2 people. Hi. So hi, Robert Moniker Guderian. Oh, that's cool. It knows my moniker. I'm so proud. But now I want to put my moniker into my name. Not going to run it. Too many values to unpack. Expect it too. At least it tells you what it expects. and the line number. So line 3, this expected 2 values to unpack. Huh. That's not an easy thing to debug. So you can see that I have 2 variables here. When I call myStir.split, what's it going to give me? It's going to give me 3 different items in a list. You can actually see the square brackets there. So it's trying to put 3 different items into 2 spaces. This is a pigeonhole principle problem if you're a mathlete, and that is bad. So it explodes and says we can't do it. This is really fragile code. I don't like fragile code, and unpacking looks really good. Generally a bad idea. Just pull them out by index. It's going to make your life a lot easier. But if you are a very cool Python person, here it is. That is the cool way to unpack tuples. And you can actually do it with lists too, and probably other sequence types. Because you can see that this is a list, and it is unpacking that list when I call, over to the code. This is a list, and then I'm saying, hey, here's some variables. It is unpacking that list. Works with tuples too. So if I had 1, 2, 3, that is exactly what's in my slide. I just looked at that. That's hilarious. This will quite happily work. And then 1, 2, 3. If we look, whoa. Once I unbreak my code, unbreak my code, say that you'll work again. Oh man, there we go. Now you can see that it unpacked 1, 2, 3 into 1, 2, 3. So that is unpacking. It's a convenience, dangerous convenience. So looking at this, so tuples are lists. No, tuples, heterogeneous data, lists, homogeneous data. If I see you mix them up, I will get angry. When I get angry, marks go away. Tuples are also immutable, so that's really good for data that doesn't change, or it really can't change. Every time you change a tuple, or think you're changing a tuple, you're creating a new one and throwing away the old one. It's very wasteful in terms of processor speed. Lists are good for homogeneous data that's changing all the time. It's actually really cool. You can make a queue with it, so you can like put in things and then pull them out the front and have data flow through. You can simulate a Tim Hortons with a list. It's actually kind of the best. But don't put a tuple when you're trying to make a queue. That would be a terrible idea. But you can see them as doing many of the same functions. So whenever you're looking at your data and looking at your program, you can sit back and say, oh, this is a collection. Is this data changing? Is this data all the same? And then make the right decision on which data type to choose. Don't just store it all in strings. So you're reading reading the names of students, giving you a list and tuple data structures. How would you store that data? Spoilers, I kind of already did that for you, didn't I? If I jump over my iPad, the students have heterogeneous data. It's a perfect tuple. Then there's a list of all of these things. And then this actually creates a very simple database. It's dangerous. I'm teaching databases right now. There's some list magic that I do want to show just because it's interesting. If you want to add them, and you can look at you should look at all the functions. I've covered most of them already. They'll just happily add, and they will be in order because it does maintain order. And addition, it'll be more like a string append. So if I wanted to do that, I first and last. No, let's see. I'll just make two new lists. Part 1 is equal to list of a range of 0 up to 10, which does what? Gives us 10 numbers, not including 10. I didn't have to put 0 there. That's me being a very pedantic person, and that is not surprising to you at this point. List, range, 100 to 1,000. No, that's a terrible idea. 110. That'll get way too big. Then I'm going to say print part 1 plus part 2. And this will actually happily work. Python is, again, slightly too friendly sometimes. And it'll have appended those two lists into a mega list. And that will work. Will this work with tuples? I believe so. Let's find out. It does. I'm not too surprised. So that is a nice convenient thing. If you want to merge some data sets, Python probably supports it. So you maybe don't have to do that on your own. If you're bored, try doing this on your own without just using the add. It's actually not the hardest thing to do. Public service announcement about equality. This is cool and terrible. 5 is equal to 5.0. So that is exactly 5 is equal to exactly 5. Floating points can get a little dicey once you accidentally have 0.000000001. There's something called floating point roundoff. And it's hard. Comparing floats with direct, like equals, dangerous game. This course used to be pretty much about that for like a month. Not really my jam. You should know it though. 2 tuples. One is 5, one is 5.0. That actually works. That works with lists too. But if you have a list and a tuple, and even though those are both sequence data types and the data inside of the sequence are the same, that doesn't work. And I guess it shouldn't. So it does check the contents of tuples list as long as it's the same type. And I guess fair enough. So tuples and lists both maintain order. They should be used for different things. Again, lists for heterogeneous data, tuples for any ordered homogeneous. Oh, yeah. No, I wrote that wrong. Lists for homogeneous data, tuples for any ordered data. I'll fix that. So I hope you're having a good day, and I'll see you next time.